In section 4, we're going to start talking about angle measure. So we want to define degree, which is used most often when we measure angles. So it is a unit of measure used in measuring angles and arcs. And we'll talk more about arcs later in the year as that pertains to circles. We're going to start off with angles. So an arc of a circle with a measure of 1 degree is 1/360th of the entire circle. So if you remember correctly, a circle measures 360 degrees. So 1 degree is 1/360th of a turn around that circle, as in the image. We also want to talk about a ray. And a ray is a part of a line. It has one endpoint and extends indefinitely in one direction. So if we're looking at the example we have over here on the right, we have point E, and then we have an arrow extending in a direction, and that is a ray. So when we name a ray, we always start with the end point. Unlike a line where we can start with any point on that line, as long as we have 2 of them, with a ray, we have to start with the end point. So I can either name this ray E, and then I have to use another point on the ray. So EF works, and then the symbol for a ray it's like a segment in a line. It's just a picture of a ray. We've got an endpoint and an arrow going in one direction. Another way I could name this ray is I could use E and then G, since that is another point on the ray. So as long as you start with the endpoint and then you pick another line somewhere on that ray, that's how we name it. Okay. Then we also have something called opposite rays, which are, in our picture, we have 2 rays. We have ray BA and we have ray BC, such that B is between A and C. So what it boils down to is if you have a line with 3 points on it, you can take the point in the middle and use that to create 2 rays, which is in our picture here. So we have ray BA and then we have another ray BC, which make up the line AC. So now we want to talk about an angle. So an angle is formed by 2 opposite rays that have a common endpoint. The rays are called the sides of the angle, and the common endpoint is called the vertex. So looking at our angle over here, there are a lot of different ways you can name an angle. As long as there's only one angle with the same vertex, the most common way is just to name it by that vertex. So we could name this angle A. You can also, if there's a number indicating what the angle is called, in our case, this would be the number 4, I can also use that number to name the angle. So I can also call this angle 4. Another way is to use the points that make up the angle. So you have your vertex, then we have points B and C. So I can name my angle, as long as the vertex is in the middle, I can either name it angle BAC, or going in the opposite direction, I can name it angle CAB. All 4 of these are the name that represent this angle that we have drawn. And notice that I have this symbol out in front here. This symbol represents an angle. It tells me that I'm talking about an angle, not just a line or 3 points. So similar to how we had symbols for lines and segments and rays, there is a symbol for an angle. Let's go ahead and do some practice. So using this image, we want to name all of the angles that have B as a vertex. So first let's locate B, which is right here. So there's a lot of different ways we can name all of these angles. I'm always just going to go with the simplest. So if I notice, I have 3 number angles right here with angle B as the vertex. So I'm just going to use those numbers to name those angles. So we have angle 5, we have angle 6, and we have angle 7. But those aren't the only 3. We also have one more angle right here with a vertex of B as well. And there's no number there, so I'm going to go ahead and name it with 3 letters. I'm going to use angle GBA. You can also use ABG as long as B is the second letter. Next, we want to name the sides of angle 5. So we have to find angle 5 so we know where it is. So angle 5 is right here. So remember, the sides of an angle are the rays that make it up. So I have my first ray, GB. So GB is one of the sides. And then my second side is right here, is this ray. And that ray, there are 2 points that fall along it. So it doesn't matter which I use. And I realized I named this ray incorrectly. It should be ray BG, because I forgot to start with the end point. So my second side, I can either name BE or BF, and I'm just going to go with BF for the second ray. And then the last question is asking us to write another name for angle 6. So let's find angle 6, which is right here. So when naming another angle, I can either use the vertex or I can use letters on the rays. And because its vertex is B, and there are a lot of different angles that have a vertex B, I'm not going to use just B to name it. So I'm going to use points on the sides. So I'm going to start with the side that has point D on it. So D, B, and then my third point, I can use either E or F. It doesn't matter which. I'm just going to go with F. So angle DBF is another name for angle 6, or you can write angle DBE. Both work. Our second example, we're going to use this image. So we want to start by naming all of the angles that have W as a vertex. So we want to find W, and then we want to start identifying the angles. Well, if I look, all of my angles have numbers there. So I have one angle here, second angle here, and I have a third angle over there, all of which have numbers. So I can say angle 1, angle 2, and angle 3. All of which have W as a vertex. I also have one more, which is the line going through X, W, and V. It is a straight line, but does have a degree measure, which we will talk about later. So it is an angle, which I would call angle XWV. Next, we want to name the sides of angle 1. So let's just highlight angle 1 right here. So we want to name the rays. So we want to start at the vertex, which is W. So one of our rays is WX, and then our second ray is WZ. Now we want to write another name for angle WYZ. So identify that angle. So we always start at the first letter and move our way. So we have W, then we want to go to Y, and then we go to Z. So if we look, that angle has a number which I can use to name it. So I can write angle 4. And because Y is the vertex and there's no other angle with that vertex, you could also use Y as the name for the angle. And that leads us right into D, which asks us to name the vertex of angle 4, which is the point where my sides meet, and it would be Y. So now we want to talk about measuring angles. And there's 3 different types of angles we can have when we draw. We can have right angles, acute angles, and obtuse angles. So if we look here, this first picture is a picture of a right angle. And right angles are usually indicated by a little box in the corner. Usually it's red to tell us it is a right angle. And right angles always have a measure of 90 degrees. Next we have an acute angle. And the acute angle in this picture is the smaller angle here that we've drawn inside a 90-degree angle. And we identify acute angles as having measures less than 90 degrees. So remember, this means less than. And lastly, we have obtuse angles. And then in this picture, the obtuse angle is this big one that extends past a 90-degree angle, and it has a measure greater than 90 degrees. So remember, this means greater than. So let's use these definitions to help us classify some angles. Now this is to measure each angle, and I don't have a protractor with me, but if you do, I highly recommend you use it to actually find the measures of these angles so we can know for sure, but I'm just going to classify them based on what they look like. So if we look at this first angle in A, it's always helpful if maybe you draw where a 90-degree angle would fall, so you have an idea as if it's greater than or less than. So 90-degree angle would go straight up from my vertex A, and my angle is below that, so I do know this is an acute angle because it is less than 90 degrees. If I look in B along the same ways, drawing my straight line up from my vertex S, my angle is below that straight line, so it is also less than 90 degrees, also making it an acute angle. And if I were to measure these angles in A and B, I would say the angle in A is probably somewhere between 40 and 45 degrees, and then in the angle B is closer to 90 degrees, so I'd say it's at least 70 degrees, maybe closer to 75 if I had a protractor. Next, we want to look at angles C and D. So the vertex in C is O, so if I were to draw a straight line going up, my angle extends past that straight line, which means this is an obtuse angle. And D, similarly drawing my straight line from its vertex I, my angle extends past it, which means it is also an obtuse angle. So if measuring these angles, if I were to guess what they measure, angle C is a little bit past 90, so I would say it's somewhere a little bit past 100 degrees, maybe closer to 110. Angle D is a bit farther, so I'd say it's probably somewhere around 130 degrees maybe. And again, if you have a protractor, go ahead and measure and see if I was close in my estimations. 2 last examples. Now without a ruler for sure, if I look at angle E, if I were to draw a straight line up from A, it would actually pretty much match up with my ray AM. So I'm just going to assume without a protractor that this is a 90-degree angle, but if you have one, please double check. So I'm going to just go ahead and say this is a right angle. And then if I look at F, I can't really draw a straight line up from I since it would fall along my ray. So this going straight up from I would actually look kind of sideways. And my angle does fall inside that straight line, so this would be less than 90 degrees, making it an acute angle. So in our last example, we want to take a look at our image, and for each angle listed, again, if you have a protractor, go ahead and measure it, but we're just going to classify it as right, acute, or obtuse. So the first angle we want to look at is angle TYV. So we start with TYV. And if I look at that angle, I do have a right angle on the opposite side. And since they share the same side and YT is a ray along the same as ray YX, this angle is also a right angle. Next, we are looking at angle WYT, so W, Y, and then T. Well, YU is straight up in that angle, which means it would indicate a right angle along UYW, which extends past it, so I can say that my angle WYT is obtuse. Next, we're looking at angle TYU, so TYU, which we already know TYV is right, and TYU is inside that angle, which means this is an acute angle. Next, we want to look at angle VYX, so V, Y, and then X, which already has the right angle indicator, so I know for certain that this is a right angle. Then the last angle we want to look at is angle SYV. And again, we've already kind of indicated that SYU might be a right angle, and this angle extends past it, which I can say that this is an obtuse angle. So hopefully this gets you familiar with how we classify angles. And if you have any questions, just please let me know.